Okay, in this next segment, we're going to be looking a little bit more about what you get when you react acids and bases. What you get is salts, but it turns out that those salts are actually still acidic and basic themselves. And we can calculate what the pHs are if we just apply the same principles we've been looking at. So the learning objectives for this segment, to calculate the pH and reaction equilibria for acidic and basic salts, qualitatively predict the results of reactions of strong or weak acids and strong or weak bases, and that's what we'll be doing. So if you have an acid or base, by definition, you get a salt plus water coming out. For example, hydrochloric acid plus sodium hydroxide gives you sodium chloride plus water. So that's just but definitional. But if you have an acid or base, you're going to get a salt out. So that's if you have a strong acid, strong base. But what if you have a weak acid and a weak base? Here we've got nitrous acid plus ammonia, and that will make ammonium nitrite and H2O. So this is a salt, but it's not quite the same because it's not a salt of a strong acid or strong base, and so it might still be acidic or basic in solution. So when a salt ionizes, one or more of both of the ions might be a weak acid or a weak base. And if those ions are weak acids or bases, then that weak acid or base will react with water to form some H3O plus or OH minus. The pH will not be neutral. So strong acid, strong base, you get a neutral salt. Weak acid, weak base, or weak acid, strong base, strong acid, weak base, you'll get something that will not have a neutral pH. Okay, but again, we could determine the pH using the exact same techniques that we've just learned. So let's just qualitatively look what's going on. So if you have a strong acid and a strong base, reacting hydrochloric acid, sodium hydroxide, hydrobromic acid, potassium hydroxide, then you're just going to get a completely soluble salt out, sodium chloride, potassium bromide, and the pH will be essentially neutral. If you have a weak base and a strong acid, you would think, that really should be somewhat acidic, and that's exactly right. So if I react ammonia with hydrochloric acid, I get ammonium chloride, and that's an acidic salt. The way to think about it is that when you react hydrochloric acid with ammonia, then the HCl donates all of its hydrogens to NH4. So what you've got is NH4 plus in water. And if you have NH4 plus in water, it's going to reach equilibrium by giving up some of its H plus, because ammonia only wants to have some of its, it only wants to be protonated some of the time, and all of it is protonated. So it will give up some of those protons to the water, making it acidic. If you have a strong base and a weak acid, well, that makes sense. It's going to be basic, right? So in this case, sodium acetate, and then you have, so when you put that in water, you will have essentially all acetate ion, but acetate likes to be acetic acid most of the time. So it will actually pull some of the H away from the water and make it basic. A weak base and a weak acid, well, it depends on the relative acidity and basicity of the ions, right? You have to know which one is stronger. So generally, whichever one is stronger. If the base is a stronger base than the acid is an acid, then it will be more basic and vice versa. So that's qualitatively what's going on.